Ratios, Part 1 by Jeff Simpson. This video is for students and their teachers and parents who are learning about ratios for the first time, or students who tried before and didn't get it. Students watching this video on their own, or with an adult helper, should be ready to stop the video when they need time to think. Each time you watch the video again, you will notice more and more details. Educators can view this video as a model for using pictures and stories to create a context of meaning that is simple and accessible and more comprehensible for many students than mere verbal definitions. So let's get started. Tom decided to earn some money working for Mrs. Newhouse, who lived down the street. Mrs. Newhouse said she would pay Tom $2 to vacuum her living room floor and front hall once a week. Tom's brother George wanted to earn some money too, so he asked Mrs. Newhouse if he could do some work for her. She said she would pay George $1 to sweep her front porch once a week. Well, the first week they got paid, Tom earned $2 and George earned $1. Down below you can see a diagram of that in the first week. The second week they got paid, same thing happened. Tom earned $2 and George earned $1. Look at the diagram. The third time they got paid, same thing. Tom earned $2 and George earned $1. In the diagram, instead of writing Tom over and George, I'm writing T and G. The fourth time, Tom earned $2 and George earned $1. Little change down below. The fifth time, Tom earned $2 and George earned $1. Surprise, surprise. Notice in the diagram, X is used for the word time, like 1x, first time, 2x, second time. Well, it happened again the sixth time. And the same thing happened every time, week after week, time after time, over and over again. Their mom noticed when comparing their money that every time Tom earned $2, George earned $1. We can write the comparison like this: Tom compared to George, or T compared to G. Or you can leave out the word compare, T to G. T to G, T to G. When comparing amounts like this, math people usually leave out the word compare. Go figure. We can also write it like this: 2 compared to 1, 2 to 1. When you see the two little dots, you read it the same way, 2 to 1. When you see 2 over 1, you still read it as 2 to 1. The math word for comparing amounts in this way is ratio. The ratio of Tom's money to George's money is 2 to 1. There are 3 ways to write the ratio of Tom's money to George's money is 2 to 1. Here they are. And they look different, but you say them all the same way. 2 to 1, 2 to 1, 2 to 1. Tom and George decided not to spend any of their money, and they liked to keep track of how much they'd saved. At the end of the first week, Tom had saved $2 and George had saved $1, so the ratio of T to G was 2 to 1. Look at the diagram. At the end of the second week, well, Tom got 2 more and George got 1 more, so Tom had saved a total of $4 and George had saved a total of $2. The ratio of Tom's savings to George's savings was now 4 to 2. That's the second time. At the end of the third week, the ratio of Tom's savings to George's savings was 6 to 3. Here's a table showing the ratio of Tom's savings to George's savings week by week. You see in the first week it's 2 to 1, second week 4 to 2, third week 6 to 3, 8 to 4, 10 to 5, and so on. How do we get these numbers? Well, here's one way. For Tom, just add 2 over and over because he gets $2 more every week. 2 plus 2, 4 plus 2, plus 2, plus 2. And for George, add 1 over and over because he gets $1 more every week. 1 plus 1 is 2, 2 plus 1 is 3, and so on. But there is another way you can do it. You can multiply the first ratio, 2 over 1, multiply it by 2 to get the numbers for the second time. 2 times 2, that gives you 4. 1 times 2 gives you 2. A 4 to 2 ratio is a 2 to 1 ratio that happened 2 times. And you can multiply the first ratio by 3 to get the numbers for the third time. You see how that's done in the diagram? 2 times 3 gives you 6. 1 times 3 gives you 3 on the bottom. A 6 to 3 ratio is actually a 2 to 1 ratio that happened 3 times. It's the same ratio. Multiply the first ratio times 4, and you get the numbers for the fourth time. An 8 to 4 ratio is actually a 2 to 1 ratio that happened 4 times. It's the same ratio. Multiply the first ratio times 5 to get the numbers for the fifth time, 10 to 5. A 10 to 5 ratio is a 2 to 1 ratio that happened 5 times, and so on. You get the idea. Okay, here's a problem for you to solve. Figure out what the ratio would be for the 11th time. Stop the video and figure it out. The ratio for the 11th time would be 22 to 11. Is that what you got? All you had to do was multiply the top number and the bottom number of the first ratio times 11. 11 times 2, 11 times 1 gives you 22 to 11. A 22 to 11 ratio is a 2 to 1 ratio that happened 11 times. Here's another problem for you. Figure out what the ratio would be for the 9th time. Stop the video and figure this one out. The ratio for the 9th time would be 18 to 9. All you had to do is multiply the top number and the bottom number of the first ratio, that's 2 to 1, times 9. 9 times 2, 9 times 1, 18 to 9. An 18 to 9 ratio is actually a 2 to 1 ratio that happened 9 times. Surprise, surprise. Here's another problem for you. Well, this one's a little different. If Tom's amount is 20, what is George's amount? Here's a hint. What number times 2 equals 20? Well, you can use division to discover what number times 2 equals 20. 20 divided by 2. Oh, 20 divided by 2 is 10. 10 times 2 is 20, so the missing multiplier is 10. Tom saved $20 after being paid the 10th time. So, to find George's amount, just multiply it by 10, because it's also George's 10th time being paid. George's amount must be 10. A 20 to 10 ratio, here it comes, is a 2 to 1 ratio that happened 10 times. Did you notice that when the ratio of t to g is 2 to 1, that you can multiply George's amount on the bottom by 2, and you'll get Tom's amount. Tom has 2 times as much as George. Another way to say that is Tom has twice as much as George. And did you notice that when the ratio of t to g is 4 to 2, you can multiply George's amount by 2, and you'll get Tom's amount. Again, Tom has 2 times as much as George. Tom has twice as much as George. So we say that a 4 to 2 ratio is equal to a 2 to 1 ratio. it's basically the same idea, the same ratio. In both cases, T is twice as much as G. And when the ratio is 6 to 3, Tom again has 2 times as much as George. The 6 to 3 ratio is equal to a 2 to 1 ratio. In both situations, T is twice as much as G. And when the ratio is 8 to 4, and watch this, if you divide both numbers by 4, 8 divided by 4, 4 divided by 4, the reduced ratio is 2 to 1. When the ratio is 10 to 5, and you divide both numbers by 5, 10 divided by 5, 5 divided by 5, guess what? The reduced ratio is 2 to 1. All of the ratios in this table below can be reduced to 2 to 1. And the top number is always twice as much as the bottom. All these ratios are equal. Before we finish ratios part 1, there is one other thing. We've been looking at the ratio of Tom's money to George's money, 2 to 1. But we could look at it the other way around, the ratio of George's money to Tom's money, which would be 1 to 2. See, if Tom's name is mentioned first, then the letter T goes first, T then G, or T goes on top and G goes on the bottom. But if George's name is mentioned first, then the letter G goes first, G then T, or G goes on top, G on the top, T on the bottom. Okay, that's all for part 1. In this video, you learned the basic ideas behind ratios. In part 2, you'll learn more about why we use ratios and see more advanced ways of working with them. You can get more practice with ratios in Chapter 9 of my book, Percents, Ratios, and Rates, which is available online at masterylearningsystems.com. And please, share these ideas with people who can benefit from them. Thanks for watching.